Okay guys, so I did an experiment with these two BLDC motors with this DeWalt 36 volt drill. This has got I think a 30 RPMs on this is 1600, as it would say anyway there, in range number 3. So 1600 RPM going through this. If you watch the video, got reasonable results. Then I tried this, and this has actually got a gearbox in it, a planetary gearbox, which is around about a 9:1 ratio. As you can see, it's hard to turn that way. You can turn, but it's geared down quite a lot. Now, just been experimenting to see which one I'd use for a bike to actually generate power. Now, what I've learnt is that neither of these are actually suitable for what I want to do, but that is very suitable. This is a 1000 watt BLDC motor, but it turns out that it's actually the structure of the motor in respect to the size. The larger you can actually order these with the magnets on the outside, the larger the torque, and that's what you actually want. You want to be able to create torque quite easily. You don't want to be creating RPM, so you want to be able to make quite a lot of power at low RPM, whereas these spin quite a speed when they're running, and then is reduced 9:1 ratio down, which gives it quite a lot of torque, but from RPM. This is around about halfway. This is I think up to about 4,500 watt motor. That's quite a powerful motor. That will really move you along on a bike. I've done 100 or 94 kilometers an hour on a recumbent with this, and I only did it once, and that's enough. I won't be doing that again, but it certainly hammers. That was with a 48 volt power control and a 1000 watt controller. So we'll be doing this. I've got a rectifying diode here, 3-phase rectifying diode. I've actually got it going up to just a temporary watts up meter. And then I've also got it going to this, I think it's a 200 watt spotlight, and also some supercapacitors. Now I've hooked this up in a few different ways, but I'm happy with the way I've got it now. So the way I've got it now is basically them supercapacitors there are 2.7 volts each, so we've got 6 of them, so that should approximately give me what, 3, 6, 8, about 15 volts, something like that. Now these charge up to 80% with just about no resistance, or very small resistance. So I've overrated it to around about 15 volts, so that I'm only really charging them ever up to 80% of the capacity. That's the theory. So I'm not met with resistance there. Now ultimately you'll have a battery as well. I've just put this in here to see the effect of the smoothing effect on the actual light, and sure enough, when I pedal, that's relatively easy. That's giving me a different reading. Here we go. You'll notice I'm pedaling sort of yet the light is relatively smooth. So then capacitors are actually storing a bit of the charge and smoothing it out, acting like a smoothing capacitor. If I stop, the light doesn't go out straight away. It's still got a bit of power from them capacitors, so that's working quite well. Now I'm going to start travelling along here a bit more smoother, and you should be able to see, if I can keep this, I'm doing about 100 watt on average. doing that quite easy. It's only a very small BMX bike and I'm 6 foot tall, so I'll have to probably put a larger seat post in it, just so that I'm getting a nicer leverage with my legs, but I'm doing that quite easy. I'm lighting that light up as bright as what a car system would. The voltage is around about 14 volts. I'm doing that easy, really easy, at about 100 watts of power. So I'm just going to go fast here. I'm getting about 200 and I won't be able to put it like that because I'm moving around too much, but I'm getting around about 200 watts of power, 180 watts of power. Stop, and you can see the effect of the supercapacitors still storing charge. So when it comes to charging, say, a lead-acid battery, what you'd do is you'd have the supercapacitors in parallel with the battery, but you'd also have, sorry, I'm a bit out of breath there, that's out now. You'd also have a blocking diode, a reasonable size blocking diode between these capacitors and the battery. The idea behind that is lead-acid batteries generally have a bit of resistance. They work in the opposite way as these. For the first 80%, or say 70%, they offer a fair bit of resistance until the water turns into acid. So you'd have a blocking diode, so these would easily accept charge from your cycling, and then they'd trickle that power into the lead-acid battery. So you wouldn't start with a lead-acid battery that's flat. Of course, you'd start with one in reasonable condition. And I think you'd use these smoothing capacitors. I think that's a good idea. I'll have to try it. But I'm thinking the resistance of a lead-acid battery might be a bit of a problem. Alright guys, hope you enjoy my videos. Thanks for watching. I just made this little system here to mount the bike in, and it works perfect. They just sit in there. So I'll just raise this seat up for a guy my size, and I think I've got something that will be quite beneficial. I'm going to be able to watch my LCD TV, which is around about 150 watts. So I should be able to earn my TV, which is the idea of anyone in this household if they want to earn their TV rights through fitness. Thanks for watching. I hope you enjoy these videos.